Okay, so the next part we will talk about general linear system. Okay. So for a general linear system, we are looking at a system with m equations and n unknowns. When we say n unknowns, mean there are n variables that we need to find the answer. Okay. And this can be related to the equation that we have always looked at for some time. Ax is equal to b, where a has a dimension of m multiplied with n, and n has a dimension of n by 1, equals to b, which is m multiplied with 1. Okay. So in this type of equation, if you remember, we can, because there are n columns, so we can write it out as n column vectors. Okay, and multiply with n unknowns. Let me expand x as x1, x2, x3, all the way to xn, and is equal to b1, b2, all the way to bm. Okay, so a and b, they are generally known, but x is unknown. Okay, and because they are n unknown, so we put them into a vectors. Okay, so if we multiply them out, I will get x1. If I multiply the left hand side, okay, I will get x1a1 plus x2a2. Okay, x1, all the x, these are all variable, so they can be any numbers. And a1, a2, all the way to an, it has the underline, so they are all column vectors. Okay, all the way to an, xn, an equals to b. Okay. So when would the solution exist? Okay. Actually, if you write it like this, like on the left-hand side, you will notice that the left-hand side is actually the same, has the same definition as what we saw earlier, right? Which is the column space. So it means that a solution exists. A solution for x exists if and only if B is in the column space of A. Okay? If B is not in the column space of matrix A, then B can never be found from x1a1 plus x2a2 plus all the way to xnan, right? Okay, so you understand, right?
อาจารย์ครับมันไอตัวหนังสือไอพวกที่ให้ add text มันบังนะครับ
Second ไอ้ box พวกนี้มันบังใช่ไหม
ใช่ครับ
Oh, I see. On my screen they look okay. One moment. So let me change this quickly. Okay. Oh, the boxes, they interfere, right? Oops. On my big screen, they are not, they don't interfere. So I didn't, I'm confused with why doesn't it appear as a slide on my screen? Okay. Did I do anything wrong? Hmm. I'm not sure why my screen. It
อา
doesn't
จารย์
show
อา
the
จารย์ลองกด
symbol.
ไอตัว powerpoint ข้างล่างตรง taskbar ดูได้ไหมครับ
มันไม่ขึ้นอ่ะ
ไอตรงข้างล่างนะครับ ที่เป็นรูป powerpoint อะครับ ข้างๆโคมอะครับ
เนี่ยเหรอ
ไอล่างสุดเลยครับ ที่เป็นตรงโปรแกรมอะครับ
ไม่ค่อยได้ยินเลยอ่ะแป๊บนึงนะอะไรนะ
ไอตรงที่เป็นตัวโปรแกรมอะครับ ข้างล่างตรงบล็อกใก
ตั
ล้ว ๆ
ที่
browser
เป็น
อะครับ
เนี่ยเหรอ
ซ้ายอีกครับผม ที่เป็นรูป powerpoint อะครับ
อันไหนครับ อันเนี้ยเหรอ
อยู่ข้างๆ Google Chrome อะครับ
ข้างๆ Google Chrome เนี่ยเหรอครับ
ใช่ครับ ที่ตรง powerpoint อะครับทางตรงกลางๆหน่อยอะครับ
ตรง power เนี่ยเหรอ
ใช่ครับ ลองกดมันเหมือนไปอยู่อีกแท็บหนึ่งอะครับ ลองเลือกอันขวาดูครับ แล้วถ้าเป็นอันซ้ายล่ะครับ
อันซ้ายมันคืออันเดิมปะ
อ๋อ
ใช่อันนี้งงว่าทำไมมันไม่ขึ้น PowerPoint ให้ ประหลาด very strange it's okay I can delete for you no problem. Is it okay now on your screen?
Yes.
โอเคครับ
No, it's okay, right? Okay. So I'll make sure that I will take it out for you, okay? Okay, so let me go back to this page. Can you see okay? I don't know why it doesn't appear here. Let me see. It's a resume slideshow. I don't know. Okay, so let's continue. So I'll try to make sure that they look okay for you, okay? Okay. So the question to us is how to find all the solutions. Okay. And we talked about it earlier after talking about the null space, right? So the answer is that the set of all solutions of the equations ax is equal to b is the set of x0, vector x0 plus y vector such that y is in the null space of A. Okay. So as an example, if you remember from previously, so previously we had A is equal to 1, 0, 1, 0, and 1, 1, okay? Where B is on the right-hand side of the equation, and it was set to be equal to 2, 1, right? And so when we write out AX is equal to B, okay, so we have 1, 0, 1, 0, 1, 1, and multiplied with X, Y, and Z, which is equal to 2, 1, okay? And Z is equal to 1. This is from the previous example. And then we have XY will be equal to 1, okay, because x plus y plus z is equal to 2, but z is equal to 1. Therefore, x plus y will be equal to 1, okay? Okay. So let's say that we let a particular answer in this case is, let me say x is 0, 1, y is 1, and then z is fixed, okay? So we call this as a particular solution. Okay? A particular solution can be anything that it is considered a solution. Okay? And we remember that so in the null space of A is equal to set of any value C multiplied with 1 minus 1, 0. Okay, you can take a look from previous example. Okay, where C is a field, or in this case, it's a real number. Okay, okay. Therefore, all the solutions, okay, are the set of a particular solution, in which case is 0, 1, 1, and then plus C 1 minus 1, 0, which is the null space, where C is a real number. Okay. So this is the what we have. Okay. Okay. So also in general, okay, when we have AX is equal to B, where A has the dimension of m by n and x has dimension of n by 1, okay. So this m is the m equations, okay, and n represent n unknowns, okay. Okay, so generally there are 3 cases involved. If m is greater than n, meaning that we have more equations than the unknowns, okay? In such a case, we call over-determined system. Meaning that we only have n unknowns, but we have more equations involved, right? So in such a case, it gives us more flexibility to find the answer. Okay. The second case is m is equal to n. In such a case, we can just find x is equal to a inverse of b. Okay. Therefore, so a must have an inverse. Okay. And lastly, if m is less than n, in such a case we call underdetermined system. Okay. And In such a case, it depends. You can find answer or you cannot find answer. Okay, but in general, you cannot find answer. Okay, except that there are some patterns in the variables that you can utilize it. Okay, and also in the case for the case of m is equal to 1, which is A is a square matrix. If A does not have an inverse, then you can find what is so-called pseudo inverse. Okay, it is a special case that is also possible. Okay, what else? Let me see. Okay, so in this case, we see that this is the solution, all the solutions, right? Why is this all the solution? Okay, because if you multiply A with x0, this is a particular solution, plus null space, okay, you will get ax plus ay, okay, but this is equal to 0 because of the property of the null space. Therefore, you get ax. So this is b. Okay. So that's how it works. Okay. Next, we will look at how to find solutions in general. Okay. Well, you can use an inverse, of course. But in general, if A is not square, then actually there are different ways to do it. If case 1, in general, case 1, okay, if A is a square matrix like n by n, multiplied with x is equal to b, okay. So if A inverse exists, then you can find x is equal to A inverse multiplied with b. Okay. So that's one way. Case number 2, if A in general is m by n multiplied with x equal to b, okay, this is n by 1. So if m is not equal to n, and in general m is greater than n, because we have like overdetermined system. So what we can do is because we cannot find an inverse for non-square matrix. So what we can do in general is we can just multiply with A transpose. Okay, then we get something like this. And then because A transpose if A has a dimension m by n, what is the dimension of A transpose? G. G, are you here?
Yeah, teacher.
Okay, if A has dimension of m by n, what is the dimension of A transpose?
A transpose n by m.
So it's an n by m, right?
Yes.
So that means when you multiply together, what do you get as the dimension or the size?
N by n.
So I get n by n, right? Which is a square matrix, right? So, and then we can do x is equal to A transpose multiplied with A inverse multiply with A transpose, and multiply with B. So that's what we do, okay? So in such a case, a solution exists if A transpose multiply with A has an inverse, okay? So these are the two main approaches in general when we want to find solution, okay? Okay, so next, let us take a look at a technique called augmented matrix method. Okay. This method is a method to help us to find solution of the linear system, and also it can help us find conditions of all solutions, whether they are solutions or not, you know, or whether the solution exists or not. Okay. So for the augmented matrix method, so it will help us find solutions, but it will transform the problems, okay, by transforming with two steps. Okay, step number one, we will augment matrix A together with vector B. Okay, and then we will use the Gaussian eliminations to transform to U and then the dash. Okay, then we will get the solution from here. From here, then we can find a particular solution. Okay, and for second step, we will try to find the null space. Okay. So let's look at this method from an example, you know, for better understanding. Okay. Oops. I think there's a slight bug in the program today. I don't know why, but okay. Okay, so let's look at an example, you know, for better understanding example, okay? So let's say that you are given that A has a form like this, 0, 2, minus 1, and 3, minus 1, 1, 2, 0, 1, 1, minus 3, and 3, 1, 5, 5, 9, okay? And then we have, let me see. Okay, let us do it in a very general method, okay? Let's say that we don't even know the B1, B2, B3, and B4. So let's keep them generic at the moment, okay? Then we can utilize this information, you know, to investigate something, okay? So for the first step, we will use the Gaussian elimination, right? So let's say that this is the line 1, line 2, line 3, and line 4, okay? So when we do the Gaussian elimination, so what will we do? So, well, there are different ways to look at it, but we will try to convert the matrix A on the left-hand side, you know, in the echelon form, okay? You notice that on the first line, this one starts with 0. So what can we do? What I'm gonna do is I'm gonna switch row, okay? Because we know that when we switch row, it doesn't change answer. The equation is still the same, okay? I'm gonna switch it with the second row, okay? So, move the first row to the second row. So I have 0, 2, oh, oops. Oh, sorry. I think I mixed it up. One moment. So I'm gonna move the second row to the first row, and move the first row to the second row. Okay. And the first row I move to the second row. B1. Okay. And then for then I will have 1, 1, minus 3, 3, B3, and last row is 1, 5, 5, 9, B4, okay. Now let's still call this 1, 2, 3, and 4, okay. So next step, what I'm gonna do is, for the first row, they look okay, okay. Second row, they look okay. Okay, and then I'm going to look at line 3, equation number 3. Okay, so first I want to reduce this to 0. Okay, so I'm gonna add equation 3 with, let's say, equation 1. Okay, so I have minus 1 plus 1 minus 1, I get 0. 1 plus 1, I get 2. Minus 3 plus 2, I get minus 1. And 3 plus 0, I get 3. Okay, and then I have B3 plus B2. Okay, because I add these two together. Okay, and then I will also look at line 4, which is here. Okay, so I will add line 1 with line 4, add line 4 with line 1. Okay, so I get 1 minus 1, I get 0. I add line 4 with line 1, I get 6. Line 4 with line 1, I get 7. Line 4 with line 1, I get 9, and etc. Okay. So you notice that here I don't care about the numbers at the back at all. I just leave it very open, you know, for some sort of general solution. Okay. So next, what I'm gonna do is I'm gonna focus on this line. Okay, and you notice that let me change to red colors. You notice that here I want to make this to be 0, right? So I will just subtract it with let me see. I can subtract line 3 prime with line 2, for example. Okay, so that's what I can do. And then for line 4 prime, okay, line 4 prime, I want to change this to 0. Okay, so I subtract it with let me write on this side. So I use 3 prime, and then I subtract it with equation 2, right? And then I subtract line 4 prime with 3 times equation 2. Okay. Anyway, so when I do this, what I'm gonna get is, I'm not gonna go in detail, okay? But this is the step that we will solve the problems. So then the next step, what I'm gonna have is, I'm gonna have first line is the same. Second line is still the same because it's already in the echelon form. And then if you notice that line line 2 and line 3 prime here, they are the same actually here. They are the same, right? So when I do this subtraction, I get all 0. So here I get all 0, okay? And if you do the computation for the last one, you get 0, 0, 10, 0, okay? I see. Also, I will need to modify the augmented vectors, okay? So for the first 2 lines, they will be the same. But for the third line, I have B2 plus B2, B3 plus B2, but I subtracted from line 2, which is B1. And then I have line 4 prime, which is B2 plus B4, minus 3 times line 2. Then I have minus 3B1. So now when you are here, you know, here we already have an echelon form. So we will call this as a U. So this is like an upper triangular matrix. And this is a B vector. I put B prime, you know, because they are different. If you look on the previous slide, it is how we write it, as a B prime, okay? And also, if you take a look at the echelon form here, okay, we have all these as pivots, okay? Okay, and so this is like the echelon form, like a step, you know, diagram, like a step, we can write it as a step line. So these are all the values on the diagonal matrix. You know, they're considered as the pivots. They are considered as pivots. So these are all pivots, okay? Okay, so that is the first step to do the Gaussian elimination and then write it in terms of the echelon form, upper triangular matrix, okay? So here we basically convert from AX is equal to B to another equation called UX is equal to B prime, okay? So all this row arrangement and also all the, you know, Gaussian elimination step doesn't change equations, doesn't change the solution for the equations, okay? And this X is just X1, X2, X3, and X4, okay? So my question is, so for this system, when would a solution exist? Okay. If you only consider this new augmented form after the Gaussian elimination, when would a solution exist? Okay. Well, because this is U multiplied with X is equal to B prime, okay, it means that, let's say if I look at the last line, okay, and I multiply the last line with X1, X2, X3, and X4, right? So what am I gonna have on the left-hand side? If I consider line 4, so I say consider line 4, okay? So I have 0 times X1 plus 0 times X2 plus 10 times X3 plus 0 times X4, okay? Oh, sorry. Let me look at line 3. Sorry, line 4 doesn't help us. Let's look at line 4. So we can use the property on line 4 to help determine some conditions. Okay, so if you consider line 3, you will have that you will have that 0 multiplied with x1 plus 0 multiplied with x2 plus 0 multiplied with x3 plus 0 multiplied with x4, which is equal to 0. But on the right hand side, you have b3 minus b2 minus b1, right? Okay. So from this line 3, we have a condition of the value on the right hand side, which is b3 plus b2 minus 1. It has to be equal to 0. Okay. So here we can say that for these specific problems of A, okay, given that A is equal to this matrix in the AX is equal to B solution, which is 0 to minus 1, 3, minus 1, 1 to 0, 1, 1, minus 3, 3, 1, 5, 5, 9, okay. Then we say that AX is equal to B, okay, has a solution in general if and only if the condition on the previous page is met, meaning that B3 plus B2 minus B1 is 0. Okay. So this is the the main condition. Okay. So now let's look at some particular solution. Okay. So now let's look at an example of finding the solution, where first we have to find a particular solution. Okay. So I do this in general. Okay. Let's say that B is equal to 4 to 0. Okay. So here you notice that B3 plus B2 minus B1 is equal to 0 according to the condition. Okay. Okay. So let's say that we are given the values for B, and in which case there's a solution because it meets the conditions up here. Okay. And it means that AX is equal to B. Okay. Here it has solutions. But it doesn't only have one solution. It may have many solutions. Okay. So if we go back to the previous page, okay, if we go to the previous page, we will notice that actually, what I can do is this. Let me go back a bit quicker. B3 plus B2. I see. Okay. I can also look at this. If I go back to the solution on the previous page, okay. For this vector, for this matrix, what I can do is I can rearrange a little bit so that they, in the form of the echelon form, I can switch between these lines, okay, between line 3 and line 4. And I need to switch these two lines as well. But then these conditions still exist. There's no problem, okay? So what I'm gonna rewrite briefly, I'm gonna do it like this. So for from the stars, from the 3 star earlier, okay, I'm gonna rewrite on the left hand side as -1120. This is still left the same. I didn't do anything different. 0 to -1, 3, 0, 0, 10, 0. I switch line 4 to be line 3, and I switch line 3 to be line 4. Okay, so that it's a little bit easier to see as an echelon form. And then on the augmented vector, line 1 and line 2, they are left the same. And then I switch line 4 and line 3. Okay, so that's all I do. Okay, and when I do this, all the solutions are still the same. The conditions are still the same. But the good thing is, in such a case, I now have this good echelon form. Okay. And because this matrix, it has to multiply with the x1, x2, x3, and x4. Okay. And you remember that previously, when you want to find solution, you always find solution from the bottom to the top, right? Okay, from x4 all the way to x1. Okay, and something you can notice is that since the pivots, okay, of the 3 lines are not 0, meaning that the pivot corresponding to x1, x2, and x3 are not 0. Okay, but the pivot for x4 is 0. Okay, so we will call x1, x2, and x3. We will call it basic variables. Okay. Then we will call x4, which correspond to the 0 pivot, as free variables, meaning that it can be anything. Okay. So this is what we will do, and okay. So I hope you're not lost. So what I'm doing now at the moment is that I let B to be some real numbers, okay, and then I just switch the U matrix in a echelon form, so that is a little bit easy to see, okay. If you don't switch between this line, there's no problem, okay. If you don't switch this line, there's no problem between line 3 and line 4, but then you have a different set of basic variables and free variables. But I just switch it because I think it looks nicer. Okay. So now, so we are still in the step number 1. So let's try to find a particular solution. Okay. Because x4 is a free variable, so it can be anything. So let's say x4 is 0, okay, just for simplicity. And then if we use the equation on line 3, okay, we will have that 10 multiplied by x3 is equal to b2 plus b4 minus 3b1. Okay, so we will have that 10 multiplied with x3, okay, is equal to maybe I should write these on the next page. 4220, okay. So we don't get confused. Okay, this is the B1, B2, B3, B4, which is 4, 2, 2, 0. Okay. So 10x is equal to B2 plus B4 minus 3B1. This will be equal to 2 minus 12, okay, which is minus 10, right? Okay, so here we have x3 is therefore minus 1, okay? And then in order to find, then next we look at the second row, okay? For the second row we have 2x2, right? Okay, 2x2 minus x3 plus 3x4 is equal to 4. Yes. Okay. So we replace this as minus 1 and then 4 as 0. Okay. So we will have 2x2 plus 1 equals to 4, or x2 is equal to 3/2. Okay. And then lastly, if you look at line 1, we have x1 or minus x1 plus x2 plus 2x3 is equal to 2. Okay, this 2 comes from here, b2. Okay, this is b2, okay, which is 2. Okay, then I get x1 is equal to x2 plus 2x3 minus 2, which is 3/2 plus minus 2 minus 2. Okay. So I will have a result as minus the 3/2. Or 3/2, minus 5.5, 5 over 2. Okay. So for here, then we have of this particular solution, and we can write it in terms of vectors. So this particular solution, in this case, is x0 is equal to minus 5 over 2, 3 over 2, minus 1, and then 0. Okay. Okay. So that's the first part for the particular solution. Okay. Next, step number 2, we need to find the null space. Okay. So for the null space, we can continue using the u as derived. Okay. So we will write the u like this. I just rewrite it in the echelon form. Okay. So if we want to find the null space, we will multiply u with the x. This x is not the, it's just the solution for the null space. Okay. If you don't like it, you can put y, maybe better, right? Let me change to y so that we don't get confused with the variable. Okay. So here I will put with y, y1, y2, y3, and y4. Okay. And set it to be all 0, so we can find the null space here, which is y. Okay. And as before, okay, this 0 pivot represent the free variables, okay, which is y4. Okay. Okay, so what we will do is we will express all the y1, y2, and y3 in terms of y4. Okay, because in this case, if you multiply this line with y1, y2, y3, and y4, you get that 0 multiplied with y4 has to be 0. So y4 can be anything, right? It's a free variables, and that will helps you generate all the solutions. Okay. So what I'm gonna do is, I have no space left. So if I look at equation number 3, I will have a 10 times y3 is equal to 0, okay? So I have a y3 is equal to 0. If I look at line 2, I have a 2 times y2 minus y3, which is 0, plus 3y4. Okay, so this is 0, which is 2y2 plus 3y4 equal to 0. So I have y2 is equal to minus 3/2 y4. Okay. So for any equation, you can find values of y. You can just find it. If you cannot find it, you try to leave it in terms of y4, because we let y4 to be the free variables. Okay. And lastly, if I look at the first line, I have minus y1 plus y2 plus 2y3 is equal to 0. Okay. But y3 is 0, so this is 0. So I have that y1 is equal to minus y2. So I just write it as 3/2 y4. Okay. So now you understand the process, right? So when we do the Gaussian eliminations, we can use it for computing the particular solution, and also to use it for computing the free variables, just for simplicity. Okay. And so in this case, I can say that, so I can just add the particular solution. So all the solutions, okay, will be the set of particular solution plus the null vectors, okay, such that y is in null space. Okay, and for this problem, the x0 that we find as a particular one solution, you can use this particular solution to be anything that satisfy one solution. Okay, so this is 5/2, 3/2, minus 1, 0. Okay, and then add it with the null vectors. Because we express it as y4, so I will just pull out the coefficients of y1 and y2. Oops, they have to be opposite, right? One moment. They have to be opposite, no? Okay, so one has to be plus, the other one has to be minus. Okay, and then y3 is all 0, so you can multiply y4 with 0, no problem. And then the last one, which is y4, so you have 1. Okay, and this is y in the null space of matrix A. Okay. And that's it. So that's the solution for this problem. Okay. Okay, out of the curiosity, let me put 4 star solution. Out of the curiosity, let me maybe try. Can anyone stop the recording? I'm gonna go to MATLAB just for a little bit.